Section 4.6 Exponential and Logarithmic Equations. In this section, you will use like bases and logarithms to solve exponential equations. Now that we've learned all of the log properties, we can now actually solve exponential equations. The first method is to express both sides to have the same base. Again, take note of this. We want to express both sides to have the same base. Example number 1. Solve 2 to the power of x minus 1 equals 2 to the power of 2x minus 4. And as you can see, they have the same base of 2. And when they have the same base, you can get the powers. Use that. X minus 1 is equal to 2x minus 4. And then now we can easily solve for x. So add 1 both sides. So x is equal to 2x minus 3. And then if we subtract 2x both sides, that is x minus 2x is negative x equals negative 3. So yes, x is equal to 3. Then letter B, solve 3 to the power of 4x minus 7 equals 3 to the 2x all over 3. But before that, let's check our answer for letter A. Since we get x equals 3, let's check that. 2 raised to 3 minus 1, is that equal to 2 raised to 2 times 3 minus 4. 3 minus 1 is 2 squared. 2 times 3 is 6. Minus 4 is 2 squared. And yes, 2 squared is 4 is equal to 2 squared 4. So x equals 3 is correct. So letter B. So what do we do here? 3 to the 2x, that is over 3, meaning this is 1. 3 raised to 1. So that's the same thing as 3 raised to 2x minus 1. Now they have the same base of 3. So we can use their exponents, set them equal to each other. 4x minus 7 is equal to 2x minus 1. And then we solve for x. So if we add 7 both sides, so 4x is equal to 2x plus 6, and then subtract 2x. 4x minus 2x is 2x plus 6. So again, when we divide by 2, x is equal to 3. Okay, so let's check. 3 raised to 4 times 3 minus 7, is that equal to 3 raised to 2x minus 1, 3 raised to 2 times 3 minus 1. 4 times 3 is 12, minus 7 is 3 to the 5th. 2 times 3 is 6, minus 1 is also 3 to the 5th. So yes, that is correct. Okay. Now let's have a quick check. For this problem, solve 5 to the 2x equals 5 to the 3x plus 2. So as you can see, they have the same base of 5. So we can use their exponents, set them equal to each other. 2x is equal to 3x plus 2. And then if we subtract 3x both sides, that is negative x is equal to 2. So meaning x is equal to negative 2. And if we check that, five raised to 2 times negative 2, is that equal to 5 raised to 3 times 2 plus 2, negative 2. 2 times negative 2 is, yes, negative 4. 3 times negative 2 is negative 6 plus 2 is also negative 4. So yes, x equals negative 2 is correct. Right, next examples. Letter A, solve 256 equals 4 to the power of x minus 5. So remember, we want them to have the same base. So we use the properties to solve exponential equations with like bases. So here on the right side, the base is 4. So now the question is, on the left side, 256, can we express this as with the base 4? So what do we know? 4 raised to 1 is equal to 4. 4 squared is 16. 4 cubed is 64. And 4 to the 4th is equal to 256. So we can actually rewrite this as 4 to the power of 4 is equal to 4 to the power of x minus 5. Now look at that. They have the same base of 4. So now we can solve this as 4 equals x minus 5. And if we add 5 both sides, so we can have x is equal to 4 plus 5, 9. So you can check. 4 to the 4th power is equal to x is 9. 9 minus 5 is to the 4th. So that is correct. Okay, letter B. Solve 8 raised to x plus 2 equals 16 raised to x plus 1. Look at their bases, 8 and 16. But we can recall that 2 raised to 1 is equal to 2. 2 squared is equal to 4. 2 cubed is equal to 8. 2 to the 4th is equal to 16. Look at that, 8 and 16. So we can rewrite 8 as 2 cubed. And you have a power of x plus 2. So that is times x plus 2 equals 16 is 2 to the 4th. And you have a power of x plus 1. So this is times x plus 1. Okay, now they have the same base of 2. So we can use their exponents. 3 times x is 3x. 3 times 2 is 6 is equal to 4 times x is 4x. 4 times 1 is 4. And 10. Now we can solve for x. So if we subtract 6, so 3x is equal to 4x minus 2, and then subtract 4x. So this is negative x is equal to negative 2. So meaning x is equal to positive 2. Okay, and I'll let you check. That should be correct. Next example. Solve 2 to the power of x plus 1 is equal to negative 2. And take note of this. This is going to be a warning. Though you can rewrite 2 to the power of x plus 1 is equal to negative of 2 to the power of 1. But here you can say that there is no solution. Alright, so why there's no solution? Okay, and I'll show you why. So we know that if you graph 2 to the x, you have a horizontal asymptote here, and this is the graph of 2 to the x. And 2 to the power of x plus 1 meaning 1 to the left. So you're gonna have like, let's see if this is 1. So this is, I'm gonna use green. This is gonna be 2 raised to x plus 1. So that is this left side here, to the power of x plus 1, so the green one. And this is negative 2, meaning that is somewhere here. Y equals negative 2. So we can say that 2 to the power of x plus 1 is going to be greater than 0. Always. It's going to be, you see the horizontal asymptote here, it's going to be above the x-axis. So we can say that this is impossible. So that's why we say that there is no solution. And take note of this, that for all exponential functions, we can say that range is all positive numbers. Okay, so take note of this. All right, so that's a warning. Next one, solving exponential equations using logarithms. In practice, we won't often be able to make both sides have the same base. So instead, we will use our friend logarithm to solve most of the exponential equations. So remember, logarithms and exponentials are inverses of each other. So what we need to do, there are steps to follow. So number 1, isolate the exponent, convert it to the log form, and then solve the variable. All right, so example number 4, solve 100 equals 20e to the power of 2t. So here's the exponent part, and we want to isolate that. So meaning we want to get rid of 20, meaning we have to divide both sides first by 20. So that 100 over 20 is 5 is equal to e to the power of 2t. Okay, step number 2, convert this to log form. So that is now log, the base of the exponent is e, so now that's going to be the base of your log, and then 5 here, and that exponent 2t is on this side, is equal to 2t. And then now we can solve for the variable t. All we have to do here is divide both sides by 2. So that is t is equal to log base e, meaning that is, remember, is ln. So this is ln of 5 over 2. Or if you use a calculator, t is approximately equal to 0.805. So either of or these two. Okay. All right, let's have a quick check. Solve 3 times e to the power of 0.5t equals 11. So step number 1, isolate the exponent. So we have to divide first by 3. So e to the power of 0.5t is equal to 11/3. And then convert this to log. So log base e, so meaning that is, yes, ln. So ln of 11/3 is equal to 0.5t. And now we can solve for the variable by dividing both sides by 0.5. So t is equal to ln of 11/3 over 0.5, or 2 to the ln of 11/3, or that is approximately equal to 2.6. Okay. Okay, next, solving logarithm equations. Sometimes we will need to solve problems with logs on both sides, and let's get practice on how to do that. All right, and to do that, I want you to remember these two things. First, you can combine logs by using the log properties. Those are the things that you learned from last section. And also take note of the second one, log x is equal to log y, meaning both sides are both logs, so we can rewrite this as x is equal to y. Example number 5, solve log of 3x minus 2 minus log of 2 is equal to log of x plus 4. The left side, we can combine that as log of 3x minus 2 over 2 equals log of x plus 4. Then using the second rule, so now we can say that this is just simply 3x minus 2 over 2 is equal to x plus 4. Then now we can solve for x. We can multiply both sides by 2. So now that is 3x minus 2 is equal to 2x plus 8. And what's next? So let's use that here. Let's solve that here. So if we subtract 2x both sides, it's going to be x minus 2 is equal to 8. And plus 2. So that x is equal to 10. Okay, we can check that. Let's use this space here. So log of 3 times x, 3 times 10 is 30 minus 2 minus log 2. Is that equal to log of x plus 4, that is 14. So 30 minus 2 is log of 28 minus log of 2. Is that equal to log of 14? Minus, meaning you can divide this. 28 divided by 2 is 14. And that is equal to the right side, log of 14. So this is correct. Okay, next example. The population of a small town is modeled by the equation P of t equals 1650 e to the power of 0.5 t, where t is measured in years since 1990. In approximately how many years will the town's population reach 20,000? Based on the problem, P is the population and T is the years since 1990. So again, the question is, in approximately how many years will the town's population reach 20,000? So the population is 20,000. The question is how many years, so we want to solve for that t, given this P of t, 1650 e to the power of 0.5 t. Now we can isolate t. So remember, we need to isolate the exponent. So first we need to divide both sides by 1650. And that is 20,000 divided by 1650 is like 12.1212 is equal to e the power of 0.5 t. Next, remember, rewrite this into log form. Log of e, meaning that is ln. So ln of this side, oops, not point, 12.1212 is equal to, that exponent is on this side, 0.5 t. And we divide both sides by 0.5. And when we do that, t is approximately equal to 24.24 years. So how many years are 24.24 years in what year? Since it's that RT, that is the number of years since 1990, so that's gonna be from 1990 plus 24.24 years, so that is approximately in the year of 2014. So think about 0.24. Okay. All right. And the next is, let's have some lecture questions. Following exercises use logarithms or like bases to solve. 17 e to the power of negative 3k plus 6 is equal to 44. First one is subtract 6 both sides. E to the negative 3k is equal to 44 minus 6 is 38. And then we can rewrite this to log form. So meaning ln of 38 is equal to that exponent negative 3k, and then divide both sides by negative 3, so that k is equal to, k is approximately equal to, if you use a calculator, negative 1.213. Okay. Number 6, 3 to the power of 2x plus 1 times 3 to the power of x is equal to 243. So let's recall, 3 to the raised to 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, and 3 to the 5th is 243. So we can rewrite this as, here they have the same base of 3, so that is 2x plus 1 plus x is equal to 243 is 3 to the power of 5. Now, as you can see, they have the same base of 3. Okay, so that is the exponent 2x plus 1 plus x is 3x plus 1 is equal to 5. And then if we subtract 1, 3x is equal to 5 minus 1 is 4. And then just divide both sides by 3. So x is equal to 4/3. That's number 6. Then number 45, combine logs to solve the following equation. ln x plus ln of x minus 3 is equal to ln of 7x plus, so meaning we can combine this as x times x minus 3 equals ln of 7x. Both ln's now, so we can cancel those out. So now this is x times x minus 3 is equal to 7x. And then now we can solve for x. X times x is x squared minus 3x is equal to 7x. If I subtract 7x both sides, that's gonna be x squared minus 10x is equal to 0. I can factor out x, and x minus 10 is equal to 0. So we have two factors here, so meaning set each to 0. So x is equal to 0 and x is equal to 10. Since we have x equals 0 and x equal to 10, but ln of 0 is undefined, so we cannot use this. So only when x is equal to 10. Okay? Alright, and the very last problem. Use the compound interest formula to solve the following equation. Problem. You set up an investment account with an initial deposit of $6,500, which earns 7.25 annual interest compounded quarterly. How many years until your investment is worth $40,000? How many years? So we want that time t. So our compound interest formula, a is equal to the final amount is equal to the initial value times 1 plus the rate over the period raised to n t. So what do we have here? A is that 40,000. We want to have 40,000 and we want to compute for that t. So your initial deposit was $6,500. Rate is 7.25%, that's 0.0725, and compounded quarterly, meaning n is equal to 4 times in a year, and we want to solve for t. Okay, so let's substitute those values here. A is 40,000 is equal to 6,500, 1 plus 0.075 over 4 raised to 4t. So let's divide both sides by 6,500. And 40,000 divided by 6,500 is like 6.15 385 is equal to 0.075 divided by 4 is 0.01875 to the power of 4 raised to t. So this is 6.15385 is equal to 1.07714 the power of t. Now to solve for t, we rewrite this exponential exponent to log form. So remember, this log of, this is the base of the exponent, so that's going to be the base of your log. 7714, and the exponent is going to be here, and this is log of that 6.15385. Okay, and now we will be able to get our t. And it's approximately equal to 24.45 years. With this, with your initial deposit of $6,500 here, after approximately 24.45 years, you will have $40,000 in your account. Okay, so that's it for this section. And if you have any questions about section 4.6, please let me know. Okay, thank you.